So it's P of X over X minus A equals Q of X plus R over X minus A. And when we're done doing synthetic division and stuff like that, which we're going to be looking at in a little bit, then you'll see what these letters even represent. For now, just write it, okay? You'll have your remainder, your quotient, your polynomial, and your factor. So in basic long division, this is what you're dividing by. So that X minus A is what would be outside of your division. So here, this would be the X minus A, but we're not going to have it because we're not doing that right now. This would be your polynomial, or what you're dividing by. Quotient is your answer. So remember, this is always what's up here is your answer, and then what's back here would be your remainder. But we're going to do it with polynomials now. Instead of like 2 into 100, we're going to do x minus 3 into x4 plus 3x squared plus blah, 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 blah. Okay. So, right, number 1. Determine the remainder, and this is what I mean by I wouldn't print them. You're literally just going to write that, and it would have been half your page. So determine, I'll make it bigger. Maybe not. I'm going to reset. Oh, I'm still recording, aren't I? So, remainder theorem, there's this thing called the remainder theorem. Remainder theorem states that if you plug in the x-intercept or the root or whatever the x value is that you're trying to divide by, if you just plug it in for all of the x values, what's left over will be your remainder. And then it would be like if I did this big long division statement, what was left over was my remainder, right? I'd have to do long division, the whole big long division thing in order to find the remainder. Well, there's actually this thing called the remainder theorem that if you do it, it gives you the remainder, but it only gives you the remainder. So if you need the quotient, if you need the answer, you have to do the long method. But if all you need is the remainder, you can use remainder theorem. Okay? All right. So I'm dividing by x plus 1. What my root would be then, so that's my factor. Remember how when we factor in grade 10, I would ask you to factor, and then you do product sum factoring or you do decomp factoring, and you'd end up with like x plus 3 and x minus 2, or 2x plus 1 and x plus 3, right? When you were done, you factored and that was what you were left with. Then in grade 11, we asked you to solve. So you had to go that one more step, that one extra step where you set them both equal to 0 and solved for x, and you got the x-intercept. Remember that in grade 11? Well, that's what we're going to do here, except it's not just going to be a quadratic. We're going to be able to do it for a cubic or a degree 4 or degree 5. We only go up to a degree 5, which is nice, okay? So right now, this is the factor. When I do remainder theorem, I plug in the root. When I do synthetic division, I plug in the root, or what x actually equals, okay? So for both of them, I plug in the same thing. So this would be x plus 1 equals 0 if we were back in grade 11. And we'd solve it. We'd move the 1 over, so x equals -1, right? Okay, that's what I'm going to use to plug in to find my remainder. That's what I'm also going to use to plug in to do synthetic division. Okay, so what does that mean? Well, remainder theorem states that if I plug in that x value, that x equals -1 in, for all the x's, I get my remainder. So I could rewrite this as p of x equals x cubed plus 4x squared plus x minus 6. Okay? Because it's a polynomial. So in that equation, the p of x would be the polynomial, the biggest thing that you're given in the question, right? Polynomial. Well, I want to find when x equals, it was -1, right? So I want to find p of -1. Because remember, this is just function notation. You learned it in grade 10 and it came with you in grade 11. And it's just function notation. So when you want to plug a value in for x, you just put it there, right? And now I'm going to plug that in for all my x's. So I'm going to get negative 1 cubed plus 4 times negative 1 squared plus negative 1 minus 6. Okay? And then I get negative 1 cubed, which is negative 1, plus 4 times positive 1, because negative 1 squared is positive 1, minus 1, minus 6. And I get negative 1, negative 1, negative 6 is negative 8, plus 4 is negative 4. So P of negative 1 is negative 4. So what does that mean? When I fill in x plus 1, the remainder is negative 4. That's all that means, right? When I fill in the opposite of this, so x plus 1, which is my factor, the remainder is negative 4. Now I'm going to prove to you that this actually works through long division. This is the only long division I'm going to show you, but I'm going to show you that it does, okay? So up here I'm going to do long division, which is not enough room, so I'm not sure why I made it so small. But anyways, long division, I'm dividing by x plus 1, so that's going to go in the front. And then in here, I'm going to have x cubed. Now, the catch is with long division and synthetic division, if you're missing a degree as you're going down, you have to replace it with a 0. You need it as a placeholder. So if it was like x cubed plus x minus 6, and this wasn't here, I'd have to go x cubed plus 0x squared plus x plus 6. Like I'd have to put a 0 placeholder in because I have to be able to count down. So 3, 2, 1, 0, I can count down. I don't need a 0 placeholder. Okay? So I'm going to have x cubed plus 4x squared plus x minus 6. Now, what did you do when it was long division before? If you had one digit, you'd look at the first digit of what you were dividing into and see how many times it went in. If it was 2 digits, like 10 into 100, you'd go 10 into the first 2 digits and see, right? You had to always go into as many digits as you were dividing by. So it's a binomial in front, so we have to look at a binomial in here. Oh, goodness. So I say to myself, I have to look at 2 and 2, right? Because I'm dividing 2 in. What times x gets me x cubed? Because I need it to match. X squared. Now remember, if you were doing this, 10 into 100, you would go like this and like this. And you'd say, how many times does 10 go into 10? And you'd say, 1. Would the 1 go here? No, it always went above the last one you were doing, right? And then you drop your 10, and you go 0, and then you bring down your 0, and you'd say, how many times does 10 go into 0? 0. And you go 10 times 0 is 0, and then you get a 0. And so you'd have your 10, but it would be at the back ones, right? So x times what gets me x cubed? X squared. So it has to go with the second one, because just like the 1 had to go above the 0, right? And then you go x times x squared is x cubed. 1 times x squared is x squared. And then I subtract it. X cubed minus x cubed is 0, so I'm not going to write it. 4x squared minus x squared is 3x squared. And then I drop down the plus x. And then I say, what times x gets me 3x squared? A plus 3, x. So I'm going to go x times 3x is 3x squared. 1 times 3x is 3x. And you subtract them and you get, this cancels, and x minus 3x is negative 2x. Bring down the minus 6. Back to this. X times what is negative 2x? Negative 2.
Are we supposed to be writing this?
Doesn't matter. Negative 2 times 1 is negative 2. And then you subtract them. Negative 2 minus minus 2x cancels. Negative 6 minus a minus 2 is what?
4. Negative 4. Okay, but why do we want to do the long division? Why is that?
You don't. I was just proving to you that just by plugging this, because if I just say, hey, just plug this in and you get it, you're just trusting me. This is proving that actually what I said is true. So you don't just trust me.
Did we ever have to use
not long division, but you will have to do synthetic division because remainder theorem only gets you the remainder. So if I want any factors, if I want x-intercept, anything like that, remainder theorem only gets you the remainder. So you have to do more, right? But if I ask you anything about a remainder, a lot of people will go and do synthetic division and do all the steps when in reality they could have just plugged in the value and gotten the remainder. So it's just time saving as well. There's also instances where you have to use it, which we'll see. Okay, so that's long division. It's one time you're going to see it, enjoy it, breathe it in, like it. Okay, so there's your remainder theorem. So you plug in what x equals, not the factor, right? When you plug it in for your x values, you get the remainder. And that's all it gives you, just the remainder. Leave a space under that, though, for synthetic division, okay? And then we're going to go to example 2. Because at the end, we'll come back and do synthetic division and prove it that way. But for the rest of this lesson, it's just remainder theorem, remainder theorem, remainder theorem. But I want to prove to you, after that question, how to do it synthetically as well, okay? For all the rest of these, though, we're just going to do remainder. You don't need to leave spaces after each of the rest of the examples, just that one example. So now we're going to do divide x cubed plus x squared minus x plus 3 by x minus 1. What is the remainder? So people see divide and they instantly want to do long division or synthetic division. Well, you don't know how to do synthetic division, so you're not pulled to that. And if you see divide, you'd be like, oh, you told me I didn't have to do long division. Now I have to do it. But all I'm asking for is what?
Remainder.
So what can I use? Remainder theorem. Okay? So x minus 1 is what you divide by. So it would actually be x minus 1 equals 0. So x equals 1 is what we're going to plug in. Okay? And then we're going to do p of 1 equals. Now we're going to plug that 1 in for all the x's, right? So 1 cubed plus 1 squared minus 1 plus 3 equals 1 plus 1 minus 1 plus 3. So it equals 4. So what the heck does that mean now? P of 1 equals 4. If I just gave you P of 1 equals 4, what would that mean to you? 4 is the remainder when I divide by what? When you divide by x minus 1, the remainder is 4. You're right, because filling that 1 in isn't actually the factor, right? That's just your x equals. Okay, you guys try 3. This one we're going to fill in x equals negative 2. Oh, when I can zoom in, my marker's so large. Okay. So we're going to go p of negative 2 equals 2 times negative 2 cubed minus 4 times negative 2 squared plus 3 times negative 2 minus 6. And you may think this is harder, but you'll also be getting ones like, for example, say you get this. Say you get 2x plus 1 is what you're dividing by. What would you fill in? Negative 1/2, because you'd set it equal to 0. 2x equals negative 1. And then x would equal negative 1/2. So you'd actually have to fill in a fraction. Okay? If you have not just x plus something or x minus. All right. So it's 2 times negative 2 cubed, which is negative 8, minus 4 times negative 2 squared, which is 4, minus 6 minus 6. So it's negative 16 minus 16 minus 6 minus 6, which is negative 32 minus 12, which is negative 44. Yeah? No?
Yes.
Okay. We're not going to do this by synthetic division right now because it's also, first off, it's not a good way to do this. So I'm going to ixnay this method. But what I do want you to do is write this down just here. Just this. When x minus x cubed plus that 5x squared plus kx minus 8 is divided by x minus 3, the remainder is 1. Find k. So just the underlined stuff. So this makes it a little bit different. Up till now, I've just asked you for the remainder. This time, they'll give you a question where you're missing a variable in the polynomial, and they give you the remainder, and then you can solve for that, missing k or missing m or whatever. And we're just going to use remainder theorem because it's really the only way that's easy. So when x cubed plus 5x squared plus kx minus 8 is divided by x minus 3, the remainder is 1. Find k. The instant you see that, you should think, I need to use remainder theorem. So whenever you're missing a variable in any type of polynomial, you have to use remainder theorem. Okay? It gives you the remainder and it gives you what it's dividing by. So it's dividing by x minus 3. So it's going to be p of 3, and it's going to equal what? 1, which is exactly what our ends of our statements looked like previous to this, right? When we were using remainder theorem, it was ended like this. When I filled in a 3, I got a remainder of 1, correct? So what does p of 3 mean? P of 3 means I take 3, I plug it in for all the x's, right? That's all p of 3 means in the polynomial. So I'm going to have 3 cubed plus 5 times 3 squared. So I'm just using remainder theorem. I'm not using this. Plus k times 3 minus 8 is just this p of 3 is this, right? P of 3 is that. We agree? And then what do I have now still? Equals 1. So I have to remember to go equals 1 at the back. Now what am I only missing? K. Just solve for k now. So if you remember this part, the solving is the easy part. It's just remembering, hey, when I see this question, what do I need to do? All right? So 3 cubed is 27, plus 5 times 9 is 45, plus 3k minus 8 equals 1. And then 27 plus 45 is 72, minus 8 is 64, right? So I'm going to get 3k plus 64 equals 1. Then I'm going to subtract 64. 3k equals negative 63. And then divide by 3. And k equals negative 21. Now, you could check this. You could check every single one of these questions and know if you're right, walking away from the test and be happy, or wrong and go back again or just cry. Okay, those are your two options you could do. Because I can take this negative 21 and I could put it in here, right? And then I could plug the 3 in for the x's and see if it equals 1. Right? So you can walk away knowing if you got it right or not. Okay, I want you guys to try this one. So we have p of 3 equals 12. P of 3 means I'm going to fill 3 into the polynomial. So 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals 12. 3 cubed is 27. Minus k times 9 squared is 9k. Plus 17 times 3, is that 51? Plus 6 equals 12. 27 plus 51 is 78, plus 6 is 84. Negative 9k plus 84 equals 12. Subtract 84. Negative 9k equals negative 72. Divide by negative 9. And k equals 8. Right? So here's where you're going to need a large amount of space. So if you think that you can do this in a small space, I'm sorry, you can't. So this is the question. I'm going to have to reduce it. So here it is. When p of x equals 3x cubed plus mx, don't write any of this stuff. Just write that. When p of x equals 3x cubed plus mx squared plus nx minus 7, so now we're missing two values, is divided by x minus 2, the remainder is negative 3. It is also known that p of negative 1 equals negative 18. Find m and n. You're going to need more space than I saved here, so make sure you have space. If you're just at the very bottom of a page, you might want to move to the next one. This question people dislike greatly because it's a lot of steps. You need to learn how to do it because it can be on your diploma and it will be on your unit test. Okay? So write this down. You don't have to write any of this stuff down here. Just write that. No. No. When you're missing one variable, you needed one divisor and one remainder, and then we could plug it in, right? When you're missing two variables, you need two separate divisors with their own remainders and plug in twice. And then we're going to have to do elimination or substitution that's been pushed through 10 and 11 in order to solve for the m and n. Okay? Yeah.
Will they ever try and like screw you over and put m and or n as like a decimal? 7.5 or something?
It's usually a fraction if they do something like that. But yeah. Yeah. Okay. So the first thing we are dividing by is x minus 2. So we're going to do p of what?
Negative 1.
X minus 2. We're going to do p of
2. Right?
2. P of 2 equals, yep, in a second. P of 2 equals what? P of 2 equals what? Negative 3. So we're going to do that one. And then we're also going to do, Connor, P of negative 1 equals negative 18. We need two of them if we're missing two variables. If we're missing one variable, we'd only need one. So we're going to plug those in separately. So we do is just like we did in the last one, except we're not actually going to be able to solve for k. Or this case, we're not going to be able to solve directly for m and n. But we'll get m and n equals number. That's the form we'll get it in the end. So let's fill it in. 3 times 2 cubed plus m times 2 squared plus n times 2 minus 7 equals negative 3. So all the same steps we've done so far, right? Except we can't just solve for the k like we've done in the last ones. So now we have 3 times 2 cubed. 2 cubed is 8. 8 times 3 is 24 plus 4m plus 2n minus 7 equals negative 3. Then just keep the m and n on the left-hand side, just like you did the k, but you can't solve for them, and then move everything that doesn't have the m and n to the other side. So 24 plus 7, or 24, sorry, minus 7 is what? 17. It's a positive 17, so we're going to subtract 17 over here and get rid of those. So we get 4m plus 2n equals negative 20, and then I box it. And we're going to do the same with the other one. So 3 times negative 1 cubed plus m times negative 1 squared plus n times negative 1 minus 7 equals negative 18. Negative 1 cubed is negative 1 times 3 is negative 3. Negative 1 squared is positive 1, so plus m. N times negative 1 is negative n minus 7 equals negative 18. Negative 3 minus 7 is negative 10. And then I'm going to add 10. So I get m minus n equals negative 8, and I box it. Now, in grade 10, you were just given equations just like this and asked to find m and n. And then you had to learn by graphing or substitution or elimination how to solve for m or n. I always just do elimination. I'm just going to do elimination because I get them in the form of elimination. So I always just do elimination because I have mn number. So you can just stack them on top of each other and do elimination. Now, I'm going to write over this, but we're still going to do this question. So I will erase and go back to redoing this question. So if you are actually filling in the notes, don't write over this question. I'm just going to do it so I don't squish it. So I'm going to write it down here and then I'm going to erase it. Okay. So I'm going to go 4m plus 2n equals negative 20. And then m minus n equals negative 8. The only way I can do elimination is if two of them are the same. So if I subtracted right now 4m minus m, I'd have 3m, and then I'd have 3n. So I haven't eliminated anything, right? So I need to make either the m's or n's the same. I'm going to make the n's the same because they're opposite signs, and then I can just add them. So I'm going to times the second whole equation, including the 8, which is what everyone used to forget to do in grade 10, by 2, so that they match. I'm going to do the entire equation by 2. So I get 4m plus 2n equals negative 20. And then 2m minus 2n equals negative 16. And then I can add them now, because if I add them, the n's will cancel. Right? So I'm going to get 6m. These are going to cancel. Equals negative 36 when I add those. Divide by 6. And I get m equals negative 6. So now I have m and I need n. So either of the boxed equations, and that's why I box them, I can plug it into either of the boxed equations and get m or n. I'm personally going to choose the second one because it doesn't have any coefficients in front of my m's and n's. But if you pick this one over here, the 4m plus 2n, and fill it into there, it'll get you the same answer. Okay? So now I'm going to plug it into this boxed one. The m minus n equals negative 8. So m is negative 6 minus n equals negative 8. Add 6. Negative n equals negative 2. Divide by negative 1. And n equals 2. Now, could you plug back in the negative 6 and the 2 and see if it works ultimately in the end? Yeah. I'll scroll back down a second. I could plug the negative 6 in for m. I could plug the 2 in for n. And then I could plug in either one of these, the negative 1, and see if it equals negative 18. Or I could plug in the 2 and see if it equals negative 3. If it does, you're right. You move on. You did good. You can walk away from the test happy. Okay? So sometimes when people get fraction answers, they freak out. But when they plug the fraction answers back in, it works, and it makes them feel better. Okay? So you can always check them. Okay, I want you guys to try this one out, the find the remainder, but what's the catch? It's 2x plus 5, so what am I going to fill in? X equals negative 5 halves. Okay, so try it out. Okay, so find the remainder when it's divided by 2x plus 5. So 2x plus 5 equals 0. 2x equals negative 5. Divide by 2, x equals negative 5 over 2. So you're going to go 2 times negative 5 over 2 cubed plus 3 times negative 5 over 2 squared minus 7 times negative 5 over 2 minus 3. So we get 2, and when you cube or square a fraction, you do to the top and to the bottom, right? So negative 5 cubed is negative 125. Negative 2 cubed is 8. Plus 3, negative 5 squared is 25 over 4. Plus 35, this would be 7 over 1. So 35 over 2 minus 3. These would be over 1s. So it's going to be negative 250 over 8. Plus 75 over 4. Plus 35 over 2. minus 3. And if I want to do this properly, I need to get common denominators. So I have to multiply this by 2, multiply this by 4, and multiply this by 8. Because you need them all over 8.
No, but why don't you just use a calculator? You just use a calculator?
Because I'm going to do proper math. Okay. Negative 250 over 8 plus 150 over 8 plus 140. Is that 4? I think it's 4. Yep, 4. 140 over 8 minus 24 over 8. And then negative 250 plus 150 is 100, plus 140 is 240, minus 24 is 116 over 8. What's 116 divided by 8?
That's a good question. I got this. 14.5.
I screwed up. Where did I screw up? I did really quick.
Into the calculator.
This is negative 250 plus, oh, good call. Negative 250, this is going to be positive 290. Yeah. So it'd be
Minus 20 over 8.
because this is 290, not 190, which is what I was saying, which totally threw it for a loop if you didn't count the extra 100. So 290, and then minus 274 is 16 over 8, which is 2.
Whole thing. We take off